In chapter 5, we will learn how to factor polynomials. We will start with factoring numbers, then monomials, and then we go on to factor polynomials. We will start with finding the greatest common factor. To factor a number means to write it as a product of two or more numbers. For instance, 6 is written as 2 times 3. So this is the factored form of 6. 12 is written as 2 times 6. This is the factored form of 12. So factoring is the reverse of multiplying. Of course, you could have many different factored forms for a given number. For instance, 12 can be written as 2 times 6 minus 2 times minus 6, 3 times 4, minus 3 minus 4, and so on. These are trivial factors because you're just multiplying by 1 or minus 1. The greatest common factor. So now what we need to find is the factor that is common to both numbers, or to a list of numbers, but it is the greatest common number, greatest common factor. It may not be necessarily the greatest factor in a specific number, but it is the greatest common one. An integer that is a factor of two or more integers is called a common factor. So first we start with common factors. For instance, 18 can be written as 2 times 9, and 24 can be written as 2 times 12. So 2 is a common factor, but we can find greater numbers that are common factor. Other common factors of 18 and 24 are 1, 2, and 3. Okay, so 18 can be written as 2 times 3 times 3. 24 can be written as 2 times 12 is 2 times 6. 2 times 6 is 2 times 6 is 2 times 3. The greatest common factor of a list of integers is the largest common factor of these integers. Now, as you can see here, 2 is a common factor. 3 is also a common factor, but if we factor uh, 18 in this form, because if you look at this, this is common to both, right? So this is 6 times 3, and this is 2 times 2, 2 times 2 times 6. So 6 is the greatest common factor. Now, what's the trick? What's the procedure to find that out? Finding the greatest common factor. Factor each number in prime factored norm. Going back to our example, so we had 18 equals 2 times 3 times 3. 24 equals 2 times, we got here 2 to the power, okay, 2 times 2 times 2 times 3. So list each prime number or each variable that is a factor of every term in the list. So now we look at the common ones. After this step, list each prime number or each variable that is a factor of every term in the list. So here we have, these are common. Okay, so we have 2, these are common, so we have 3. Choose least exponents, use as exponents on common prime factor the least exponents from prime factor forms. Okay. This is just in case we had, so here this is 2 to the power 1, okay, this is 2 to the power 1, and this is 2 to the power 3. Okay, this is what they mean, choose least exponents. So here we choose 2 to the power 1. Multiply the primes, so we multiply these and we get the greatest common factor. So the greatest common factor is 6. If over here we don't have any more common factors, any primes, common primes, then the greatest common factor is 1. Okay, this is useful when we're trying to do that, something we should memorize. What are the numbers that are divisible by 2? Any number that ends in 0, okay, like 10, of course, it's divisible by 2. 30, divisible by 2. Any number that ends in 2, okay, for instance, 32, because it's an even number, divisible by 2. Any number that ends in 4, of course, so 24 is an even number. Okay. Also 6 and 8. So numbers that end in 0, 2, 4, 6, or 8 are divisible by 2, because these are even numbers. What whole numbers are divisible by 3? The sum of its digits is divisible by 3. For instance, the number 21 is divisible by 3 because 2 plus 1 is 3, and 3 is divisible by 3. So 21 is divisible by 3. 21 is equal to 3 times 7. Okay. Also, 120. Okay, divisible by 3 because 1 plus 2 plus 0 equal 3. If you use your calculator, you will see that this is 3 times 40. So 120 is divisible by 3. Crazy number maybe 111 is divisible by 3 because 1 plus 1 plus 1 is equal to 3. And you can write 111 as 3 times 37. A whole number is divisible by 4 if the last 2 digits form a number divisible by 4. 1, 2, 2, 122. is equal to 4 times it. Okay, why? Because the last two digits, right? The last two digits are divisible, form a number. Oh, sorry, not. The last two numbers must divide. Okay, not 122. For instance, 124. Okay, the last two numbers are 24. Okay, 24 equals 4 times 6. 4 times 6. So 24 is divisible by 4. So 124 is divisible by 4. Okay, 124 equals 4 times 31. Okay, so you don't add like in the previous case. The number itself, 24, should be divisible by 4. For instance, 112. Okay, 12 is divisible by 4 because 12 equals 3 times 4. So 112 is divisible by 4. 112 can be written as 4 times 28. Okay. A whole number is divisible by 5 if it ends in 0 or 5. This is probably more obvious. Okay. 10 ends with 0. Obviously, 10 is 2 times 5. 15 is 3 times 5, and so on. Okay, multiples of 5 probably are the easiest to deal with. You can look at those. They are not as useful as the previous ones. All right. Find greatest common factor of 30 and 45. We start with 30. Okay, this is an easy way to factor numbers. Okay, 30. 30 is an even number, so it's 2 times 15. Okay, and 15 is 3 times 5. Okay, we cannot go any further. So 30 is 2 times 3 times 5. 2 times 3 times 5. 45. Okay, 45 is not even. Okay, so it divides 5 though. Remember, 5 is a prime number. So it is 5 times 15. No, 5 times 8, 9. Okay, 5 times 9. Yeah, I forgot my multiplication table. So 5 times 9 is 44. 9 is written as 3 times 3. So this is the factorization of 45. 3 times 3 times 5. 3 times 3 times 5. Okay. The common ones. Okay, the common ones are this and this. Okay, in the first case, it's 3 to the power 1. In the second case, it's 3 to the power 2. So we use the smaller one, 3 to the power 1. Another common factor is 5. In both of these, it's 5 to the power 1, so we use 5 to the power 1. Multiply those, you get 15. So 15 is the greatest common factor of 30 and 45. Find the greatest common factor. Numbers. Okay, 50 and 75. 50 equals 2. Actually, let's start with, because 5 here makes it easy for us, equals 5 times 10. 10 equals 5 times 2, and we cannot go any further. Okay, these are all now prime numbers. So 50 is 5 times 5 times 2, 2 times 5 times 5. 75. 75 is, if you divide 75 by 5, remember 75 ends with 5, so it divides 5. So 75 is 5 times 15. 15 is 3 times 5. And here we cannot go any further. So it's 3 times 5 times 5. This is the factoring of 75. Now, in the first instance, these are the common ones. Okay, the 5 in the first instance is 5 to the power 2. In the second instance, it's 5 to the power 2. So this is the smallest one that is common. So the greatest common factor is 5 to the power 2. The greatest common factor of 75 and 50 is 25. 12, 18, 26, and 32. 12 is easy. 12 is 3 times 4. 4 is 2 times 2. Okay, so 12 is 3 times 4. 4 is 2 times 2. So this is 12. 18, we did that above. 18 is 2 times 3 times 3. 26. 26 is even, so it's 2 times 13, and 13 is prime. You cannot factor it anymore. 32. 32 is 2. Let me do it over here. 32 is even, so 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Okay, so now 2 is a prime. So it's 2 to the power 5. 2 times 2 times 2 times 2, 5 times. Okay, the 2 in the first one appears 2 to the power 2, in the second one 2 to the power 1, in the third one 2 to the power 1, and the last one it's 2 to the power 5. The smallest one is 2 to the power 1. Okay, so you have 2 to the power 1. That's with the 2. 3 does not appear here or here. So the factor 3 is not a common of all of them. And that's it. Because the first one has only 2 and 3. We don't need to look any further. 3 is not common, so we're done. It's 2 to the power 1. The greatest common factor of these numbers is 2 to the power 1. Okay, 72, 120, 432. 72, again, remember 72 is an even number, so 72 equals 2 times 36, I believe. Yes, 36. 36 is an even number, so it's 2 times 18. Okay, 18 times 2 is 36. 18 is an even number, so it's 2 times 9, and 9 is 3 times 3. Now all of these are primes. We cannot go any further. Okay, so it's 2 times 2 times 2 times 3 times 3. We get this. Okay, 120 is done similarly. It's exactly the same procedure, except more calculation. Now, the first prime that is common is 2, and in all of these, okay, it's 2 to the power 3. So you have 2 to the power 3. The second one that is common, second prime that is common is 3. In the first one, it's 3 to the power 2. And the second one, it's 3 to the power 1, which is this. And in the third one, it's 3 to the power 3. So we choose the smallest one, 3 to the power 1. And that will give us the greatest common factor. So 2 times 2 times 2 is 8, times 3, 24. 24 is the greatest common factor of these three numbers. Okay, find the greatest common factor for each list of numbers. 22 is easy. 2 times 11. 23 is a prime number itself. So the only factor we have for it is 23 times 1. Of course, you can have this, but this is useless. And 24 is, as we have seen, 2 times 2 times 2 equals 3. All right. If you compare these, there is no common factor. Okay, between the first and last, 2 is a common factor. Only 2 is a common factor, but 2 does not appear in the factoring of 23. So the greatest common factor is the trivial 1. Okay, 10 is 2 times 5. 11 is a prime number. So the factoring of 11 is simply 11 times 1. So there is no common factor other than 1. The greatest common factor is 1.